We present BG Triangle, a novel vectorized 3D scene representation. Let's start with the definition. A 3D scene is composed of BG triangle primitives. The geometric shape of a primitive is determined by a set of control points. Adjusting the positions of these control points alters the 3D shape of the primitive, enabling it to represent both linear and curved contours. Using barycentric coordinates defined on the surface, we can calculate the corresponding 3D coordinates of a point. During rendering, we generate Gaussian subprimitives at the surface point corresponding to each pixel to model the object's appearance. The attributes of each Gaussian subprimitive are interpolated from its coordinates in the attribute maps or the Bézier color space. The Gaussian subprimitive features a soft, rounded distribution, which leads to blurry edges during rendering. To suppress this uncertainty, we employ discontinuity-aware alpha blending, which utilizes vectorized boundaries to recalculate the Gaussian distribution. The effect of a boundary on a Gaussian distribution is determined by the distance between the Gaussian and the boundary, as well as the boundary's width. When the boundary width is very small, a sharp boundary rendering effect can be achieved. Our method uses a coarse point cloud as initialization and reconstructs a vectorized representation from multi-view images. During training, the proposed splitting and pruning process enhances representation by subdividing surfaces that lack sufficient capabilities in local space while simultaneously reducing redundant ones. Our method represents objects with varying levels of granularities. At coarser levels, a primitive shares the same set of attributes to represent large areas, making it highly efficient in utilizing information. BG Triangle is also capable of extracting 3D line strokes that represent the structural features of the object. We compare BG Triangle with other methods under a comparable number of parameters. Although these methods utilize varying Gaussian densification strategies, our approach consistently outperforms others with a comparably small parameter count. Moreover, the BG Triangle vectorized compact representation reduces runtime memory overhead while delivering clear and sharp images. Thank you for watching.